Hello, Josepa. My name is Alish Badia, and Merry Christmas and Happy New Year. I wish you Happy New Year. And I will explain to you the aircraft control systems. It's something that we can see in our quite day-to-day life, and I think it's something quite interesting. Okay, what's an aircraft control system? First of all, um, we all know what's a control system, so it's kind of the same, but in an aircraft. We have that kind of help of control of recalculation of the inputs for the aircraft to have a better flight. We'll see now. First of all, what are we going to act on? The control surface. We have three kind of control surface. The main control surface. In a normal plane, like the basic plane, we have the aileron that will provide this kind of move, elevator, up and down, and rudder. Okay. The conventional flight control, like the first controls, would be this, push and pull ropes. It's something very mechanical and very basic that it's not able to be used on the new kind of airplanes because the huge size, weight and everything and the speed they are going, it's impossible to control such a plane with this. Okay, so here appears the hydraulic systems. Hydraulic systems will provide the pilot with that help of power that will make able for him to control the airplane. This is a modern control surface in an aircraft. We have the basic ones, aileron, elevator and rudder, but it also appears the tailplane, air brakes, spoilers, flaps, a lot of things that wouldn't be able to control with just on a stick, and then we would need a lot of sticks. It's not possible to fly like this. So now we have control systems that help us to control all these things. So, as I say, the size of this kind of planes makes a need of power control systems. Here appears the hydraulic systems that makes the pilot able to control the aircraft. So now we start to talk about the control. In airplanes, it's called fly-by-wire system. It's a computer configured system that appears between the pilot and the actuators. So will be kind of a filter, kind of a control. It's absolute a control to control the airplane. Okay. First of all, this kind of aircraft needs a lot of redundancy. We say need because an aircraft it's something that will be flying very high, it's something quite dangerous. So if just one actuator fails, we need a lot of redundancy to be able to react safely to this kind of problems. Here you can see, it is written here on the top, triplex, quadruplex. Okay, here I explain it. This is the diagram of aircraft. As you can see in that part, I'm not able to cross the screen because if I do it, the camera just don't film correctly. At the left part, as you can see, there's a control column. That would be the input of our system. It's the pilot trying to control the aircraft. Then that signal goes to 4 computers. That's a point of redundancy, having 4 controllers simultaneously. And then, after applying all the parameters, the signal goes to the control surface. Then in the control surface, we have potentiometers that will make the closed loop control, like if I explain it here better. Reference would be the inputs of the pilot. Then we would have our controller. The system would be the control surface. And then we have potentiometers in that control surface that will provide the output. That's the sensor, the potentiometer, that will go to the reference, and that would be the error that goes to the controller. Basic operations, it's what I have said, that triple or four, it could be even quadruplex computers working at the same time to provide redundancy and a very safety control. And we also have another system. We have the pilot, the controller, the control surface, the sensors. Okay, but there's another one, kind of parallel. We have gyroscopes that would be sensors that provide to the controller in which position is the aircraft, and will send that information to the controller like a second input that will be exactly the same as the pilot, and will make the aircraft to respond to the position of the aircraft, making that the flight would be more comfortable, you know? Okay. This is the diagram where you can see the aircraft sensors at the left, the aircraft cockpit at the right, and the control commands at the bottom. And in the middle we have the controller, 2 inputs, 1 output. Here would need that another sensor would close the loop with each of the systems, but okay. Here the redundancy I have explained, the quadruplex signals that will make that redundancy, because if one fails we need redundancy to react correctly to that problem. And the advantages that have this kind of controls. Talking a lot of the gyroscopes, there's turbulence suppression, because if there's a little move while the flight is in automatic control flight, you know, flying automatically, there's no need of the pilot to correct that. The airplane corrects it for himself. We have been talking about fly-by-wire systems like something with analogical technology, but it's also possible logically in digital technology, because nowadays what we're using is digital technology and provides a wide range of possibilities while controlling and talking about this. Here it's explained how the system works again. It's about the same of the analogical. It's like the input, the control, the system, the output with the sensor, and close the loop. It's the same, but just that the controller, it's not a PID controller or something like that. It's a computer that have his own differential equations that will make the whole aircraft works correctly. Here is explained the redundancy in the digital ones. The sensors, the redundancy explained before, it's more about the controller. But now here it's explained the redundancy in the sensors. For example, if one control surface have more than one sensor, that's redundancy. And if one of the sensors fail, the controller just reboot that sensor, ignores it, to continue with the correct control of the aircraft. And there's also control in the engines to have a correct consume of the fuel. Also, there's control in the throttles, the everything have controls to increase the efficiency of the aircraft. And finally, autopilot systems would be another control system. It's not inside the plane, it's communicated with the GPS that will tell how the airplane should be moving to, through GPS, be in a route continuously. It's something quite easy. It's just that point it's quite out of the route. We have to recalculate it and goes in again. And that's all. I wish you have liked it and thought that it's interesting. Merry Christmas again. See you. Thank you. Bye bye.